How's it going?
Good. I like these morning
I'm just kidding.
Mine is nice and
Yeah.
sharp.
Right?
Yeah.
I like them later in the day a bit.
Do you?
Because that's when I get like everything else done.
I usually like the 8 o'clock appointments. I'm so burned out by then that it's hard for my mind to think clearly. But in the morning,
Yeah, I'll remember that.
I'm nice and fresh.
Okay. Well,
What do we got?
I'll remember that next time. Just more stuff on the site. Let me go there real quick. I'm there. I just need to get some of the lessons. Just a moment. I'm getting ads. Hold on. Okay. So we're going to 9:30, maybe a little bit longer. We'll see.
Okay.
Sorry, I'm on a hotel internet right now, so it's pretty slow.
Okay.
Oh my goodness gracious, it's taking forever.
You're on a hotel's Wi-Fi network?
Yeah. Okay.
Especially with GoToMeeting already loaded. That's a
Yeah, it's
very,
a little slow.
it's GoToMeeting's a real chip hog.
That's true.
Uses a lot of your computer resources. That's why I don't use the webcam. If I turn the webcam on, it really
Yeah, it's super slow.
slows everything down. Yeah, so I stopped using it.
Okay. It keeps giving me like graph ones. I'm trying to stay away from those because they take too long. I don't have that much time this morning.
In the future,
All right, let's do
you
this
might
one.
want to take a screenshot or something in advance of our sessions so we don't have to waste so much.
Yeah, that's true.
You really want.
Well, usually it's all set up.
You want to be ready at 9 o'clock with problems so that we can make the maximum use of our half hour.
Okay. All right, so the thing I have for this morning is find the given functions of fog x and GOF of x, and it's f of x equals 6x plus 1, and g of x equals x, the square root of x. Yeah, it's just the square root of x. Okay.
So what's fog? Do it step by step.
Fog is f of g of x. So it's pretty much just f of x, the square root of x. And then we just plug that into the f equation, right? Or is it the g equation?
It's always that equation.
Okay, so then we plug it into 6x. So it would be a 6 parentheses square root of x.
Actually, you don't actually need the parentheses there.
Oh, I don't need the parentheses?
Well, normally when you're plugging something in, you do if it's got more than one term. But since this is a monomial term, square root of x, parentheses don't do anything. Multiplication is implied regardless. Now, if it was square root of x plus 1, then I would have put it in parentheses. I had to multiply both of it by 6.
Alrighty.
Okay, now what's GOF?
It's g of f of x. So we have the square root of 6x plus 1.
Hold on. Let's do it step by step.
So then it's parentheses 6x plus 1.
Step by step until you can do it perfectly every time. So what do I throw in for f of x?
It's a g parentheses x 6x plus 1.
Okay. Now what's that equal to?
Okay, and then it would be the square root of 6x plus 1.
There you go. Okay. What else?
All right.
I think you're getting pretty good.
What did you say, sir? Yeah, I'm getting them a bit better.
I mean, I think you know how to do fog and goff, no matter how complicated the functions are.
That's true.
Now,
okay. We have to find the domain of each now.
Fog is equal to x, then the g function is the inverse of the f function. Have you dealt with that yet?
I don't think so.
Okay. You haven't dealt with inverses?
A little bit, but I don't think that.
Okay.
Yeah.
That's the definition of inverse, is that the f of the inverse has to be equal to x. In other words, it's
f of the inverse
of the inverse of f. That's what that means. So that, by definition, has to be x. Likewise, the inverse, minus 1, of f of x also has to be x. So if they give you two functions and they say prove one is the inverse of the other, just do fog or goff, either one of them, and if they produce x as an answer, then one is the inverse of the other.
Oh, okay. So they're just inverse. Well, how do we define the domain of those two?
Inverses usually come at the time they're teaching you about composites, because you got to do composites before you can really talk about inverses.
Alrighty.
So what else you got?
Okay. Hold on. So what would be the domain of those two things? Would it just be x then, or?
Were you talking about the last two functions? Or in other words, you're talking about the f of x equals 6x plus 1 and the g of x
the domain
square root of x. What's the domain on the f function?
The domain, it's 6, right? Am I a little off?
All possible values that x can take. That's the definition.
Oh, okay. That's all real numbers, right? On that one.
And on the other one?
Is that one real numbers too?
Can you take the square root of a negative number?
No, you can't. So it's just all positive real numbers, right?
It's all positive or 0. There's your domain right there.
All positive or 0.
Yeah, okay. You can take the square root of 0. It's 0. You can't take the square root of negative 1.
Okay.
Okay. So that's the domain for each one of them. Now, when we did goff, if you remember, goff was equal to the square root of 6x plus 1. Well, now we have a different domain on this.
That's true.
Solve for this domain.
That's all. It's all just positive real numbers as well, right?
No. Again, you cannot take the square root of negative numbers. So we cannot allow 6x plus 1 to be negative. And the way you do that is you take whatever's in the radical, no matter how complicated it is, and you say 6x plus 1 has to be greater than or equal to 0.
6x plus 1 has to be greater than 1.
Yeah, that gives you a domain of minus 1/6.
Okay.
However, because this domain of the original function always takes priority, this domain isn't needed. We know that x has to be greater than or equal to 0. Just because we've put it into a composite function and we have a different domain, The fact is that we can't let x be equal to minus 1/6. It works for Goff, but it doesn't work for the g function. No way x be equal to minus 1/6 in that function. So this takes priority. In other words, if you have a number line, the bottom one says there's minus 1/6, here's 0. The bottom one says it can be any number there. But the original domain says it has to be greater than or equal to 0. Well, the original domain is more restrictive.
Okay.
You use that. Am I hearing dogs in your background? Or
no, that's just my siblings.
It's what?
Yeah, they're my siblings. Just a second, I'll be right back.
No, I'm not worried about it. It's just I didn't know if my dog was in pain or not. My dog is outside my door, so I'm hearing what sounds like dog sounds, but I wanted to make sure it was on your end and not on my end. Because otherwise I need to go check on my dog.
Sorry about that.
No problem.
All right, anyways, so let's move on to the next one.
Okay. We did that last one before.
Yeah. So this one is find f of x, g of x, and h of x equals f of g of x. And the equation is h of x equals parentheses 2x plus 5 parentheses squared.
And they're giving us h of x, and they want to know, they're saying h of x equals f of g of x, and they want us to tell them what f of x is. Is that correct?
Yeah.
Okay. Well, let's experiment. These, where you have to go backwards, they want us to tell them what both of these are.
Wait, hold on. I think I'm wrong. It says, right, it gives us a bunch of options, and it says choose the correct pair of functions.
Okay. I don't need the options. I'll tell you what the functions are.
Okay.
F of x is 2x plus 5, and g of x is x squared. Now, that doesn't make h of x be fog, but it does make it be Goff. In other words, I got it backwards, perhaps. Perhaps, it depends on what did they say h of x was?
Let me look.
Was it f of g of x, or was it g of f of x? Or did they even say? Did they just say h of x is a composite of f and g?
Yeah, I'm going to read the problem. It says find f of x and g of x such that h of x equals f o g of x.
Okay, so I've written it exactly right here, but I got the wrong functions. Notice what f of g of x would be the way I've written it. It would be f of x squared, which would be 2x squared plus 5, which is not the answer. But notice if I reverse, if I let that be x squared and let g be 2x plus 5, now when I do fog, I do f of 2x plus 5, which would be 2x plus 5 quantity squared. So here's what I did, how I figured this out. I look at that, and I know one function has to be the inside, and the other function is the square function. Okay? So I knew one of these had to be x squared, and one of them had to be 2x plus 5. And I really have to just check what f of g of x is under this scenario. And if that doesn't work, try g of f of x. And if g of f of x works, then switch the two functions. Because they're telling me that h of x is equal to f of g of x. So f has to be x squared, the outside, and g of x has to be the inside. Let's do another of these.
Okay.
These are fun, they're hard. They're a little bit of trial and error, but you can generally figure them out. You just have to be, this is why they give you so many practice problems on composites, because you got to be perfect at it, quickly at it, and then you can do them backwards.
Alrighty.
That's what we're doing, is doing them backwards.
All right.
Actually,
are you asking for the next problem yet?
Yeah.
Okay. Can I see the answers for the other one real quick? The two functions.
Mm-hmm.
I think, oh, never mind. I think it's right here.
F of x was x squared, and g of x was 2x plus 5.
Excellent. Okay. Yeah, that's one done.
Okay.
Let me go to the next little thing we got here. It is. I'm just checking to see all my stuff, what we got going here. What's nice is that you've helped me. Almost all of my assignments are like completed now.
Good.
Which is really important for me.
Yeah, completing the assignments is big, but understanding the material is more important.
No, that's why I'm working with you so hard here.
Yeah.
Okay. Hold on, this next one right here. Oh my gosh, there's ads opening up everywhere. Why is it doing this? Okay, it's
on a hotel Wi-Fi network.
Yeah. So it says, for the function f of x equals 6x minus 5, construct and simplify the difference quotient. And it's f parentheses h x plus h, minus f of x over h.
Yeah. The beginnings of calculus.
Oh, yeah.
Here is the definition of first derivative. It is the limit of f of x plus h minus f of x all over h as h goes to 0. Now, they're not giving it to you as the limit of first derivative, or that's the definition of first derivative, but they want you to do that part right there. Well, it's not as hard as you think. First, figure out what f of x plus h is.
X of h of x, or what did you say? Okay.
Figure out.
So that would.
We're going to need both of these things. Notice what the thing says. It's f of x plus h minus f of x. Well, we know f of x, but we don't know f of x plus h yet. Let's fill it in. You know how to do this. Plug in whatever's in the parentheses wherever you see x.
Okay, so would we plug the h plus, or the x plus h into the...
Whatever's in the parentheses. Doesn't matter how simple or complex. Whatever's in there, you plug it in for x.
Okay. Would it be plugged into the 6x minus 5?
Wherever you see x.
Okay.
Yes, on the f function.
So it would be...
In other words,
so it'd be,
let's back up a second here.
Okay.
If I say f of x equals 6x plus 5, and then I say to you, what is f of 2? You plug 2 in for x. If I say, what is f of x squared minus 1? You plug x squared minus 1 in for x in parentheses. So this would be 6 times x squared minus 1 plus 5. That's how you do it. Whatever is in the parentheses, you plug in. So what is f of x plus h?
Okay. So it would be 6 parentheses 8. Wait, hold on. No, yeah, it'd be 6 parentheses h or x plus h plus 5, or yeah.
End parentheses.
And plus 5 at the end there.
Plus 5.
Yeah.
Now that simplifies to 6x plus 6h plus 5. So that is what f of x plus h is. Okay? Now, what they want us to do is f of x plus h minus f of x. So for me to do that, I do 6x plus 6h plus 5 minus the quantity, the function f of x. Well, the function f of x is 6x plus 5. All divided by h. You with me?
Yeah, I got you so far.
And remove the parentheses from the top. What are you left with? And simplify.
Would we get 6x plus 6h plus 5 minus 6x plus 5, right?
Minus 5.
Minus, so that's right, the negative
distribution. Sign has to be distributed to that term.
Okay, that makes sense. My bad.
Okay, so we'll start with 6x plus 6h plus 5 minus 6x minus 5. Notice that everything without an h in it disappears. The only thing I have left is 6h in the numerator. And in the denominator, I have h. So the h is now.
So it's just 6.
The answer is 6. And what you've done is taken the first derivative of the f function. That's how you take first derivatives. What are first derivatives? They're slopes.
Slopes?
That's what a first derivative is a slope. If I say it's a slope of a tangent line. In other words, if I have a function that looks like this, it's curved, and I say, well, what's the slope of the tangent line right there? What's the slope of that line? The way you determine it is by taking the first derivative and going through the process you just went through on that problem. And we would have figured out that for the function we're talking about, the slope of the tangent line was 6, always. The slope of the line,
that makes sense.
The slope of the line is 6. Notice that that's in y equal mx plus b format. The slope of that straight line is 6. So when we took the first derivative of it by doing this f of x plus h minus f of x all over h, that's how you find the slope of a more complicated function. This is a linear function. It's got the same slope everywhere. Straight line doesn't change slope. So the slope is 6 no matter where you're at.
Alrighty.
Okay, you got another one of those?
Not for today. I gotta go soon, so I appreciate your help a lot. If I have time today, depending on when I get home, I might use you later tonight, but I'm not entirely sure yet.
I got most of my day is open today, so I got.
Okay, we'll see.
Okay.
I'm probably going to be using you a little extra, like I have been this whole week for a couple more weeks.
That's fine.
Just to let you know, because I need to like catch up on stuff.
Okay.
And then everything will be cool. All right. Thank you for your time today. I appreciate it. All right, bye.